So this problem is from the back of your test outline, and we're just going to go through and work it so that we have a good idea what's going to be on our test. So I have these constraints. X is greater than 0 and y is greater than 0. So if I do the x one, the x one's going to talk about the x-axis, and when it says x is greater, so we're going to, y is greater, we're going to shade up. The x one says that x is greater than 0, so we're going to draw a vertical line on the y-axis, and it says positive, so we're going to shade that way. So we're looking really only at the first quadrant. The next equation, I'm going to subtract the 2x over. And then I'm going to divide by 2. So when I go graph this in the first quadrant, my y-intercept was a 5. And then my slope was a -1. So I have this line, and it said that y was bigger, so I would shade up. Then my last equation, I'm going to get 2y is greater than or equal to -x plus 6. Y is greater than or equal to -1/2 x plus 3. And then you go down 1 over 2, down 1 over 2, down 1 over 2. So we have this line, and we're going to shade up. So when I go to shade, shading everything in the first quadrant, and along the red, then along the blue, along the x-axis, everything in here. All of this is going to get shaded. So then the problem wants you, now that we have this bounded region, I'm going to go up and down forever. It wants you to find maxes and mins, and where the maxes and mins are going to occur is on the vertices. So the vertices are the order pairs of the shaded region, the corners. So this one is 0, 5. This one right here is 4, 1. And this one right here is 6, 0. So I'm going to take those three order pairs, and I'm going to plug them into my objective function they gave us to figure out what maximizes or minimizes my objective function. So what I like to do is I like to kind of make a table. So I put the order pair down here. This is my work. This is my value. So I'm going to use the objective function and plug in the order pairs. So the first order pair I had was 0, 5. So if I plug 0, 5 in, I'm looking for that z value. I get 8 times 0 plus 7 times 5. That results in a 35. 4, 1. 8 times 4 plus 7 times 1. 32 plus 7 makes a 39. And then I had 6, 0. So it's going to be 8 times 6 plus 7 times 0, which is going to result in just 8 times 6, which is 48. So we'll go down to the next one. It says find the value, find the maximum value. My maximum value was 48, and that occurred at the ordered pair 6, 0. My minimum value was 35, and that occurred at the ordered pair of 0, 5. So you have another problem on this page. Go ahead and pause the video, and then when you're done with the other problem, you can restart the video and the answer will be on the screen for you. So I went through the same process and I had to graph my objective functions. This time my shade region was actually bounded, and that you could see what happened because right here, y was less than. So one was going to shade up, one was going to shade down. So I had my bounded shaded region was a triangle, 3 vertices to plug in. Over here I did the same thing. I plugged them in to find my values. My maximum value was 112, my minimum value was 4, and they occurred at 16, 0, and 0, 8, respectively. So we'll be something like this on your test where you're going to have to graph 3 or more lines, find the vertices, plug them into the objective function, and figure out where the max or min occurs and what that value is.